All right, welcome to This Explainer. Today, we're going on a seriously mind-bending journey to try and visualize massive numbers. I mean, we hear words like millions and billions thrown around literally all the time, right? But do our human brains actually comprehend that kind of scale? Well, let's break down these colossal figures by looking at one really fascinating number, a lakh. Just how big is it really?
To set the scene for you, I want you to meet Eshwarappa. He's a farmer from the town of Chintamani in Karnataka. So he's on a pretty regular trip to the market to buy seeds for his rice field when he overhears a conversation that just completely stops him in his tracks. A man named Ramana is explaining that historically, their country had about a lakh, which is 100,000 or 1 lakh varieties of rice. Just let that sink in for a second. 100,000 unique varieties of a single grain. Historically, farmers preserved these distinct seeds, though today only a handful of varieties remain in common use, and local seed banks are trying to save the 100 or so indigenous seeds they can actually find. But 1 lakh, that number is just staggering.
So naturally, when Eshwarappa went home and shared this massive figure with his kids, Roxy and Estu, it sparked an incredible puzzle. And I want to pose the exact same question to you that his son Estu pondered. Estu realized, he'd only tasted maybe 3 varieties of rice in his entire life. He wondered, if you tried a brand new variety of rice every single day, would you even come close to tasting all 1 lakh varieties in a full lifetime of 100 years? I want you to actively think about the math here with us. Does 100 years give you enough days to hit 100,000?
Okay, to solve this, let's ground the concept in something we all know. If we ignore leap years just to keep the math clean, we've got 365 days in a standard year. So to find the total days in a 100-year lifetime, we simply multiply 365 by 100, giving us 36,500 days. Wait a minute, 36,500, that's not even halfway to $1 million. So even if you tried 1 rice variety every single day for an entire century, you'd still be tens of thousands of bowls short. No way, right?
The astonishing mathematical truth is actually this. If you wanted to live for 100,000 days, it would take you 274 years. That is well over 2.5 centuries just to experience 1 lakh days. So the really crucial point here is that when we take an abstract number like a lakh and anchor it to our personal, everyday experience of time, like eating 1 meal a day, it suddenly feels overwhelmingly, impossibly huge.
Let's pivot from time over into physical space, because it's really tough to sense spatial scale without a solid baseline. Meet Somu. He is exactly 1 meter tall. This gives us a highly familiar human-sized measuring stick. If we look at the building right next to him and we estimate that each floor is, say, about 4 times Somu's height, we can start to visually calculate the massive height of that entire structure just by mentally stacking Somus on top of each other.
And this 1 meter baseline brilliantly helps us scale all the way up to monumental heights. Check this out. Here we see the Statue of Unity in Gujarat, the world's tallest statue standing at about 180 meters, next to the Kunchakal waterfall in Karnataka, which drops from an awe-inspiring height of 450 meters. By using our 1 meter baseline, we can actually start to comprehend these colossal spaces. The Statue of Unity is roughly 4 times the height of Somu's entire apartment building. And that waterfall, you literally have to stack multiple massive buildings just to reach the top. It proves that huge numbers, whether we're talking days or meters, really only make sense when compared to something intimately familiar.
Which brings us right back to Eshwarappa's children and the core debate of our explainer. After realizing how many years it would take to eat a lakh of rice varieties, Eshwarappa asked Roxy and Estu a simple but profoundly deep question. Is a lakh big or small? This totally split the siblings into 2 completely different camps, and honestly, their debate perfectly captures exactly why the human brain struggles so much with large numbers. Let's look at their respective arguments.
So, Roxy? She firmly believes that a lakh is a huge number, viewing it entirely through a lens of sheer awe. First off, she argues that 1 lakh varieties of rice is simply an overwhelming amount of agricultural diversity. Second, as we calculated earlier, 1 lakh days stretches out to 274 years, a time frame no single human can physically experience. But her third point is, I think, the most striking visual. If you took 1 lakh people and had them stand shoulder to shoulder in a single line, that human chain would stretch for 38 kilometers. Just imagine driving in a car for 38 kilometers and passing a continuous, unbroken line of people. From Roxy's view, for sure, a lakh is a giant, imposing figure.
But then, Estu's counter-argument completely flips the script. Estu thinks a lakh is actually tiny. Why? Well, think about that 38-kilometer line of people Roxy just mentioned. S2 points out that you can take that exact same 100,000 people and comfortably seat all of them inside the cricket stadium in Ahmedabad. Suddenly, a sprawling 38-kilometer line shrinks down to fit into a single localized building. Even crazier, a standard human head holds somewhere between 80,000 and 120,000 hairs. That means a whole lock of something can fit right on top of your scalp. And out in nature, a single female fish can comfortably lay almost 100,000 eggs at once in a tiny underwater nest. Some even lay tens of locks at a time.
So, what does this all mean? Who's actually right here? Is a lock a massive 38-kilometer line, or is it just the hair on your head? Well, the answer is both. This brings us to a super fascinating concept called numerical relativity. This is the idea that abstract large numbers completely lack an inherent sense of size until we anchor them to specific physical spaces, timeframes, or objects. A lock of days is an absolute eternity, but a lock of fish eggs? That's just a speck in the ocean. The number itself is really just a multiplier. It's the physical context we apply to it that gives it weight and scale in our minds.
Now, to handle these massive concepts globally without our brains melting, we use commas to avoid impossible walls of digits. But there are actually different global systems for this. The Indian system, which is also used in places like Bhutan, Nepal, Sri Lanka, and Bangladesh, groups digits from right to left in a 3-2-2-2 pattern. This creates the groups we call thousands, lakhs, and crores. In stark contrast, the American or international system groups digits in a uniform 3-3-3 pattern, giving us thousands, millions, and billions.
Let's systematically walk through this translation so you can permanently anchor these two systems in your mind. 1 lakh in the Indian system is 100,000 in the American system. Now add a 0. 10 lakhs is equal to 1 million. Add another 0, and 1 crore is equal to 10 million. Finally, at the very bottom, if we jump all the way up to a 1 followed by 9 zeros, the Indian system calls this 1 arab, or 100 crores, which perfectly translates to 1 billion in the American system. It's the exact same mathematical reality, just formatted slightly differently by culture.
Honestly, understanding these systems is really all about mastering place value, the idea that a digit's position dictates its actual worth. To show you that large numbers are just flexible building blocks, let me introduce you to a conceptual tool we call Creative Cheaty. Cheaty is a totally different kind of calculator. Instead of regular number pads, it only has place value addition buttons, +1, +10, +100, +1000, all the way up to +1 million. Cheaty teaches us that any large number can be constructed in multiple, really creative ways depending entirely on which mathematical building blocks you choose to press.
Let's actually prove how understanding place value allows you to deconstruct numbers like this. Say Cheaty wants to build the number 5072. You might immediately think, oh, just press the +1000 button 5 times. But Cheaty gets a little creative. First, pressing the +1000 button just 3 times gives us 3000. Next, pressing the +100 button 20 times adds 2000, bringing our total to 5000. Finally, pressing the +1 button 72 times finishes the whole shebang off. 3000 plus 2000 plus 72 equals 5072. By playing around with these specific button presses, we see that large numbers aren't rigid monoliths. They're totally fluid structures made up of smaller, digestible parts.
Wow, okay, we've covered a lot of ground today. We started with the story of a farmer marveling at a lack of rice varieties, realized that a lock of days actually spans centuries, and discovered that a lock of people can stretch for 38 kilometers or just cram right into a single stadium. We've seen how commas help us tame these wild figures, and how numbers can be playfully deconstructed. But I want to leave you with one final provocative thought. If just one lock, 100,000, is this dependent on context, and this mind-bending to accurately visualize in our daily lives, what does a billion actually look like? Think about that 274 years we talked about and try to multiply it. I challenge you to take everything you've learned about physical scale today and apply it to a terrifyingly larger number. Thank you so much for exploring this with me, and definitely keep questioning the scale of the world around you.